Hey everyone, my name is Sam Hum, and together with Frank Stinar, Haejin Lee, Jeff Ginger, and Chad Lane, we created the classification of natural language descriptions for Bayesian Knowledge Tracing in Minecraft at the University of Illinois. And today I'll be giving you a brief overview of our project. Scientific observations are one of the most challenging and important skills for science, but students often need educational support to shift their casual observations to those that are more scientific. Thus, we proposed the application of Bayesian Knowledge Tracing, which is not commonly used in informal video game environments like Minecraft, and open learner models to provide feedback to middle school students on our Minecraft server. Our data was collected from two separate sites, a Midwestern United States Community Center and Midwestern United States Middle School. At the Community Center, students are more gender balanced, predominantly African American and from lower income families. Students from the middle school were majority Caucasian and male. The ages of students from both sites range from 11 to 15 years old, and they participated in 5 camp sessions that lasted 3 hours each. At the camps, they interacted with our What-if Hypothetical Implementations or WHIMC server, where they can explore and make observations in-game on what-if scenarios on Earth, like what if Earth had no moon, or exoplanets, which are planets that are not in our solar system like TRAPPIST-1e, and learn how the different circumstances on these planets affect their environment. Now I want to talk about the machine learning component of our project. Due to the ambiguity of observation correctness, we decided to focus on the observation structure using a machine learning classifier. We leveraged the pre-existing coding scheme to categorize our 1,341 camp observations into 7 categories: analogy, comparative, descriptive, factual, inference, off-topic, and measurement state. The distribution of these observations are shown in the graphs. Due to differences in students and language used in our observations compared to those in pre-existing datasets, we took an exploratory approach to selecting a machine learning pipeline with a careful consideration to equally weigh underrepresented groups using sample weighting based on the campsite and synthetic minority oversampling technique or SMOTE for underrepresented observation categories. We then used tenfold cross-validation to compare common text preprocessing, vectorization, and machine learning models. The result of our experiment is shown in this table. We found models using the pre-trained vectorization model Global Vectors, or GLOVE, performed worse than all other pipelines. Thus, we conclude that models using middle school text data from different student demographics should use custom vectorizers to account for language differences. We will now show you how we use the classifier in-game. Students use in-game tools to categorize and write their observation. It is then compared to the model's prediction to assess correctness, to update our BKT model. The student is then presented both correctness and open learner model feedback, depending on if the classifications match or not. Our project is still ongoing, as we need to collect more student self-classified observations to make a more representative BKT model. And we need to run future tests to see if our tools actually do support long-term STEM interests. But we're very hopeful about the future of our project. And this concludes our presentation. We want to thank you for listening and learning about our project, and we hope you enjoy the rest of AIED 2022.